Lesson 1, page C98. In the next few sections, we're going to be talking a lot about the solar system. In this particular lesson, we are going to learn about the effects of the Earth's rotation and revolution. Also, about the effects of the Earth's tilt. Let's go ahead and get started and make sure you're following along. What are the effects of the Earth's movement? Sunrise, sunset. You may have watched these events many times, but have you ever wondered what causes the sun to appear and rise and set? How would your life be different if the sun did not set? Earth's rotation and revolution. Did you know that the Earth is always moving? It never stands still. One way Earth moves is by spinning around its axis. It spins or rotates just like the ball in the picture. Imagine that you draw a line from the finger up through the ball. The ball is spinning around the line. Earth also spins around such a line or axis. Each time Earth makes one full spin on its axis, it makes one rotation. And a rotation is simply just one full spin of an object around its axis. Let's go ahead and take a look at the next page. Notice in the picture that only the part of the Earth facing the sun is lighted. This part of Earth has daytime. The part that is not lighted has nighttime. It takes Earth 24 hours or a day to make a rotation. So on Earth, we both have a daytime and a nighttime every 24 hours. As Earth spins, it also moves or revolves around the sun. Just as you have a route or a path that you follow to school, Earth moves in a path around the sun. The path of Earth is called its orbit. One full orbit around the sun is one revolution. Earth takes 1 year to make one revolution. That's about 365 days. Just think, every time you celebrate a birthday, Earth has made another trip around the sun. Gravity is a force of attraction that causes Earth to revolve around the sun. Without gravity, Earth would fly off into space. The force of gravity between Earth and the sun keeps Earth in its orbit. It's important to know on these two pages that simply that Earth's axis is an imaginary line through the Earth around which the planet rotates, and that the gravity keeps the Earth in its orbit around the sun. One more interesting thing before we turn the page, and that is a complete orbit or revolution, and that's pretty much the path that the Earth takes around the sun. It's approximately 365 days, but it's also 6 hours and 9 minutes. Go ahead and turn the page. Effects of the Earth's tilt. Notice the picture below. They show how the tilt of the Earth affects the way different parts of the Earth receive sunlight. Notice the difference between the northern part of Earth and the southern part. We're going to get started from June to September, where we have summer. That's not the case elsewhere. The northern part of the Earth gets the most direct sunlight from June to September. During this time, the northern part of the Earth has summer. Down below, the southern part of the Earth gets more indirect sunlight when the northern part gets direct sunlight. So, from June to September, the southern part of the Earth has winter. If you lived in Argentina at this time of the year, you would have fun in the snow. December to March. The southern part of the Earth is tilted towards the sun from December to March. During this time, the southern part of Earth gets the most direct sunlight. The southern part of the Earth now has summer, even though it's December and March. Down below, the northern part of Earth is tilted away from the sun from December to March. During this time, the northern part of the Earth gets indirect sunlight. The northern part of the Earth now has winter. On the next page, look at the picture on page C100 again. Notice how Earth is tilted when the northern part of the Earth has summer, as this time the northern part of the Earth gets more direct sunlight than the southern part. Sunlight, as shown as the picture, is from the sun's energy. The more energy from the sun that reaches Earth, the more sunlight heats Earth. Direct rays of sunlight are not spread out as much as indirect rays. Therefore, the energy of direct rays is not spread out as much, and they heat Earth more. Think about this. Suppose Earth's axis was straight up and down, not tilted. When the direct sunlight would hit the same spot of Earth all the time, the part of the Earth near the equator would always have summer. The northern and southern part of the Earth would have milder weather all year long. So you can see it is the tilt of the Earth that causes the seasons to change. On these two pages, it's interesting to note that the axis of the Earth is tilted at an angle of 23.5 degrees, and because it is tilted, it causes the seasons to change. Make sure you fill out your questions, and the secret word is revolution. There are 365 days, 6 hours, and 9 minutes to make a revolution around the sun. Thank you.